one function. We will talk about function. Can you see this slide? Okay, good. Function. Oops. Okay, function. Can I start, class? Can I start? Chapter 5? Okay, Amar. Okay, thank you. Okay, before we talk about chapter 5, I try to show you the relationship between chapter 5 and chapter 4. Okay, chapter 5, previously we talked about relation from A to B. In this arrow means from, here means from, here means to. So in order to represent relation between all the element in set A and all element in set B, we represent by this symbol. It means have a relation.
Boleh.
Okay, sorry. Again, assume we have at least two set here, A and B. We try to make a relation from A to B. Then, if that is there any relation, we put this symbol R. So we can represent by A have relation with B. If do not have relation, we put like this one. Sometimes we also can map from A map to A. So we can represent by A have relation with A. Okay, if do not have relation with A, we put like this one. Okay, that's the relation in chapter 4, and we also talk about form of relation. We can present through statement, and metric relation we represent by MR, and the third form we can represent by diagram. Okay, now this all talk with all this thing chapter 4. Now we move to chapter 5. Chapter 5, we talk about relation. We focus on this relation. It means we focus on this arrow, where we assume that A have relation with B. We put like this symbol. For chapter 5, we concentrate specifically on this R, where this R means relation. Any relation, for any relation, actually it can be either as a function, or can be not as a function. So in other words, once we talk about any function, actually we talk about relation. But once we talk about relation, doesn't matter. We talk about relation. Sometimes it is a function, sometimes it's not a function. Now today we will talk about this function, this sub chapter. So the question is, which one is function, which one is not function? Okay, 5.1. Before we talk about function or not function, we must know what is the definition of function. We start with, we assume that once we have A and B, it means set. This set is non-empty set. Non-empty set means each of set have element, at least one element. So a function f means this function f from A to B, is a relation from A to B, where for all A is element is the element in domain F, where we put as FA, where F relation set of A contain one element of B. See, just one element in B. Okay, then that function we put as FA, actually mapping or mirror to B, where B came from this set. So this relation Previously we talked about this relation R. Now change to this relation F can be described as the first element A, the second element, where sometimes we put as a B, now we change to function of A, where it means A element in domain F. So what means by this statement? This statement means previously we have A map to B, and if there any relation we put R. Now from A to B, once we identify this relation as a function, we put as F. Look like F, but this is a unique symbol represent FF. So this F actually from A to B, where previously in this relation we put as, if have a relation A, have a relation with B, so we put A, B. Now once we specifically on function, we focus on function, this symbol change. This symbol will be first, once A, FA actually map to B. It means this function from a specific A, where this A, one of the element in A, in set A, and it map to one element in B. So once B represent like this one, when we consider this representation, it will be A, we change this B with this function, it will be FA. That's why we get this representation. So we change to B as A with function of A. It means we need to specify each of the relation in between A and B, in set A and set B. So now once we have a relation like this one, so we call this one is a function. Okay, then we look on the idea, means we try to visualize the idea of function. So in function, this arrow we call mapping or transformation. So we can visualize the idea where from set A map to set B, we call mapping here. We don't call arrow or relation. We call mapping from set A to set B. How it map? We specific to element in A, specific actually this point, focus on A, we map to B, focus to B, specific to B, where B equal to function of A. It means this B actually is mirror from function of A. Why we get this one? Because of once we talk about A have a function with this arrow, this mapping, so we put mapping to where? To B. That's why equal to B. What's on the line? Okay, clear. So this idea actually came from specific, from A to B. This B reflect by FFA, this one. So all this A we call argument, where this argument actually of the function F. That's why here we change to F, not BSR. So now F. So where this A we call argument. So once we map to B, where this B actually based on the mirror from FA, so we call this FA as a value. So this value actually map from the argument. So under this F, this is we call image under image under F. Image under F. So this argument is referred as image under F. So that's why we get this formula. So this formula to show that relation is a function. Okay. So for KR class, the differences between relation and function. Function we write based on this formula and we put here F, not R. Okay, now we move to example 1. How we identify this this function? So given to you, A have element 1, 2, 3, B have element A, B, C, D. Now once we have a function, C function, so it means 1 map to A, 2 map to A, 3 map to D, 4 map to C. So we can call that F1 is equal to A, F2 equal to A, F3 equal to D, F4 equal to C. So how we visualize this idea? Through this figure. See? You look on this one. 1 map to A, 2 map to A, 3 map to D, 4 map to C. In other words, we can see that in A actually is domain A. Okay, in A, at least we have one mapping go out. All the elements must have one. Cannot be more. One, for example, here in A, value 1 have one mapping, so can be as a function. 2 as a function, 3 as a function, 4 as a function. Only one go out, but come inside can be 2 or 3, can be 1. Here A can be from 1 and 2, D from 3, C from 4. This is a function. Function, one of the condition, once we call that relation is a function, each of the element in domain have one relation, one mapping here. We consider as a domain. We talk about domain only. We do not talk about range. Here is range B. But in order to identify this relation is function or not, each of the element have one mapping. That's function. Okay, see, since each set Fn is a single value, F is a function. Means this mapping we call as F is a function because in domain they have only one mapping. Each of them have only one mapping. That's a function. Okay. So the basic question, how we differentiate this is function, this is not function? So in function there are 4 types of relation. So between these 4 types of relation, only two types can be called as a function. The others we call not a function. So what is the type of that relation? First is one-to-one relation, one-to-one. So one-to-one from 1 here to this value. It means only one mapping from 1 to A, from 2 to B, 3 to C. This is a function. Another thing, many to one also have a function. Here from domain, each of them have a relation and one mapping. But for domain, for range, here share two element mapping from set A. Doesn't matter. This one can be. This is many to one. It means many to one means here 1 more than 1. Here 2. Maybe we have another value for map to A. Also can be as a function. As long as it can be identified as many to one, it means function. However, for the other type, of relation, one to many and many to many is not a function. So the function, any relation we call function once it fulfill either one to one or many to one. That's the basic idea of function. Clear? Actually, it is a relation, but once it the type of relation is one to one and many to one, that one is function. But one to many to many is not a function. So far so good, class? So far so good? Okay tak? Anin saja, okay tak? Ini pasti sudah makan dah. Okay, Kai, thank you. Syarul, thank you. Okay, now we move to next idea, next example. Okay, second example, given to you A 1 to 3, B, X, Y, Z. So please consider this relation and this relation. Okay, which one is a function? Okay, R 1 map to X, 2 map to X. S 1 to map to X, 1 map to Y, 2 map to Z, 3 map to Y. See, look on, in order to identify function or not, look on the first element, means the first one. Okay, here is from A map to B. Look on the first one. So the first one is from set A. Set A have 1, 2, 3. So it means in order to make sure that either R or S is function, we need to utilize all this value have one mapping. All this value. If only 2 can be as a function, look on R. So here, the first one have mapping to X. Second have mapping to. How about 3? They have no mapping. They have no mapping. So it means not a function. Because we need R have a mapping also. Only one mapping. But for S, 1 to X, 1 to Y, okay, 2 to Z, 3 to Y. So it utilizes all the element in A. This one is a function. So if we look on this R and S, so S is a function. S is a function, R is not a function. See? Function. S not a X, Y, Z. So terbalik ni. R is many to one. R is a function, S a okay, sorry. Again. R is a function, yes. Sorry. R is function as long as we have many to one. Sorry. I'm wrong previously. Okay. Many to one. So many to one, R is a function. So we have here many to one. Either R is not utilized, is still many to one. Here is many to many. Here. Many to many here. And because 1 involves 2, it means many. Y involves 2. So we assume many is not a function. Okay, this one, 3 actually is equivalent. I'm confused with equivalent. Later we will talk about one-to-one relation. Sorry, this one-to-one relation. This is not one-to-one relation. This is still a function, even though we do not utilize 3. As long as here we utilize 1 and 2, even though here map to X is 1 to many. Okay. Actually, they have another idea under function one-to-one. I'm confused with one-to-one once we talk about 3. Okay. Now we move to composition of function. Okay, again, once we talk about A to B, once we identify this one is function of A. How about once we have more than one mapping? We have A to B, B to C. So another second mapping we call G A. Why we put GA? Because of this A actually came from this value from set A. So we can have more than two mapping from A to B, B to C. So this we call composition of function. So the ratio between this one and this one, we put like from here to here. So we put from, like F composition with G, F, G. So relate based the relation based on A. Or we say this G inside this F. So we can put as G, A inside F. Either one. Both we call composition of function. We can assume the idea like this one. This is F, F. So this is F. And inside F there are G. So this one FA, this one GA. Okay, we can visualize the idea of composition of function is like this one. Okay, we assume that if G is a function from A to B and F is function from B to C, we can say that a function of F and G can be put as this F composition with G. So we put like this one or like this one. And that's composition. Okay. For example, given to you A, B, C, Z. Okay. A, B, C, Z and C is set of even number. So C is a even number. So let F A map to B. A map to B linked by this function. B map to C linked by this function. So that function represented by A plus 1, G function represented by 2B. So now we have A map to B, B map to C. So A map to B have a function. So what is A map to B? Represented by F. This function actually diff F A is represented by A plus 1. So B to C represented by GB. So this function actually is represented by 2B. So the question asks you, what is the FGA and GFA? So FGA from here to here and to here. GFA from here to here and to here. So look on this example, this is the answer. So based on F have relation with G, so we put like this one, it will be FGA. So we identify GA. In this question given to you, GB equal to 2B. So we just change GA will be 2A. So we just replace GA with 2A. Then this 2A inside F. So F actually is A plus A plus 1. So A plus 1 is A plus 1 represented by F to A. So this to A actually, this to A represent actually as a. Okay, that's why this A we change to 2A. It will be 2A plus 1. So this to A mapping to this A. This one fixed. That's why we change this A with 2A. So the answer will be 2A plus 1. That's for composition between F and G. Now we move to the second question, composition between G and F. So FA inside G. So we put like this one. So FA actually represented by a plus 1. So we change this a to a plus 1, automatically this function we draw out. So it will be a plus 1. So this a plus 1 actually represented by GA. So this a plus 1 will map to a. So GB equal to 2B. So this B map to this one. So because of here GA equal to GA plus 1, so this one will be replaced as this B. So actually it will be 2A plus 1. So it will be 2A plus 2. So please do not confuse between these two answers. So far okay? Composition. Okay class?
完全不期待。
Anin aja, okay dah? Composition of function.
如果无使我较厉害数学，当今
I would like to give a question from this subtopic. So put a star for this composition of function. Tengah faham. So if you look on this question, you need to understand first this figure. From this question, we try to simplify from this idea.
主要是我
So any question given to you, try to simplify through this
所以我
representation. So from here to here. So from here to here, this is inside here. So just replace, then put inside this A. From here to here, here just replace inside B. Actually, it's easy. Okay. Now, given to you this exercise 1. So exercise 1 given to you, FA is A mapped to B. GA is B mapped to C. So we can identify that A mapped to B mapped to C. So here we put as FA. Here we put as GB. So this FA actually represented by this function A minus 1. This GB represented by B square plus 3. So what is the question? The question said that GF2. Now here is not A. Here is 2. So how we solve it? So we put the answer as previous solution GF2. So then it will be G. So this F actually equal to F2 equal to A minus 1. So it will be, we change, actually this is A. It will be 2 minus 1. 2 minus 1. It will be 1. So it will be, here the answer will be 1.
Yeah.
These two refer to this A. So 2 minus 1 will be 2, 1. So this one will be as a value G1. So G1, once we look on this G, is means B square plus 3. It means we refer to this B. So it will be, once we change, it will be 1 square plus 3. It will be equal to 1 plus 3. 4. That's the answer.
Oh.
Okay. The second idea here. Now we have FG2. We consider on G first. So G we talk about B square plus 3. So F we change. Actually this is B. We change B square with 2 square plus 3. So it will be 2 square plus 3. So it will be F4 plus 3. It will be F7. So it will be as F7. So we look on FA. So FA actually A minus 1. So we focus on A. So A minus 1. So because of here A equal to 7. So 7 minus 1. So it will be A minus 1. So it will be 7 minus 1 is 6. That's the answer for B. Now FGAY. So as actual previously FGAY, so we put FGY. Just replace with Y only. So FGY. So B square plus 3. So it will be B square plus 3. So it will be Y square plus 3. So now, in order to make sure the final answer, so F will refer to A minus 1. So is A minus 1 actually represented by Y square plus 3. So it will be Y square plus 3 minus 1. So it will be Y square plus 2. That's the answer. Okay, class. Okay, good, Vivian. How about the others? Yeah, okay, good. No Nazifa? Okay tak? Okay, bagus. Okay, Ismail, Ahmad Ismail, good. The others? How about the others? Okay, any question related to this subtopic? Selina, are you okay? Okay, good. Okay. Okay, now we move to the next idea. Okay, this exercise 2, I hope you can do it by yourself. I don't want to show the answer. Just based on this exercise, I think you can solve this exercise 2. Okay. Okay, now finish 5.1. We move to 5.2.
Hả, coi cả.
Okay, 5.2. 5.2 we will talk about special type of function and invertible function. So what is the special type in function? Okay, this one. Previously I'm confused with one to one here. Okay. Once we talk about function, when we focus on function, where the function constrained on many to one and one to one and many to one. Now we look on the special type. What is the special type? The special type in function, there are three special types in function. First, we call everywhere defined. Everywhere defined, actually it means we look on the domain of function of A. It means once we have A, set A map to set B, everywhere defined means we focus on set A only, where we focus on DOM function, means set A. It means we need to look on all these set need be to utilize. The second idea we call onto. Onto, opposite for everywhere defined, we focus on set B, where we focus on RAN of A. So we just talk about, or we look on set B only. And the third special type is one-to-one. One-to-one means once we have this element mapped to this element, this mapping only one-to-one, not many to one. So now we look on this example. We say given to you function 1a, 2a, 3b, 4c, where the first element, the first set 1, 2, 3, 4, 1, 2, 3, 4. The second set, which is set B, A, B, C, D. So we assume like this one. Set A, and the others is set A, set B. So in set A, we have 1, 2, 3, 4. All the elements we must put dot. Huh? This dot means the location of that element. If without dot, it means the total of element involved. So we put dot here. Dot 1, dot 2, dot 3, dot 4. It means this value, the element is number 1, number 2, number 3, number 4. And in B, dot A, dot B, dot C, and dot D. So the first idea here is said 1 map to A. 1 map to A. Then say 2 map to A. 2 map to A. 3 map to D. 3 map to D. 4 map to C. 4 map to C. Okay. Now we look which one is that. Sorry, is that everywhere defined onto or one-to-one? So that based on this mapping, it is it is where everywhere defined because we utilize this one that I confused previously. We utilize all these elements, means all the elements used in this mapping. So we call everywhere defined. So we focus on domain. We utilize all the element in domain and we use all, it means everywhere defined. Okay. Then onto. This mapping, this F represent all these things. Not onto mapping. Why? Why? Because of this mapping only utilize A, C, and D, not B. It means not onto mapping. So if 2 map to B, yes, it will be onto mapping. In other words, everywhere defined focus on all the elements used in set A. Onto focus on all the elements need to be utilized in the function. Here we do not utilize, so not onto. Another one is that one-to-one? No, because of here 1 map to A. Suddenly 2 also map to A, 2 not map to B. So this is not one-to-one mapping. If these 2 map to B, so all have their own mapping, and this mapping one-to-one, so we call one-to-one. That's the differences between everywhere defined, not onto, onto and one-to-one. Okay, clear? Class. This is a special type of function. How to differentiate between all these three based on this special type. Everywhere defined, focus on domain. Onto, focus on range. One-to-one type represent to one-to-one mapping. Okay. Second example. Given to you A, B, C, D. So try to find the mapping between all these function given to you. Okay, now first function we talk about A and B. See A and B. So first A map to B, here F1. So we look on A, we look on B. So A have A1, A2, A3, dot, dot, dot. B have B1, B2, B3, dot, dot, dot. So F1 say A map A1 map B2. So A1 map B2. A2 map B3. A2 map to B3. A3 map to B1. A3 map to B1. Okay, see? The question asks you, is that is everywhere defined, one-to-one or on-to? So for F1, this question, so is that everywhere defined? We check. All the element, these three elements, utilized. Yes, everywhere defined. Everywhere, so everywhere defined. Good. The second idea, onto. Is that all the element in B utilized? Yes. Onto. Onto. Yes, onto. Is that one-to-one? One-to-one? We look. One A here. Yes, one-to-one. Yes, one-to-one. 1, 2, 1. So F1 fulfill all the special type. This one cover all. So it also yes for everywhere defined, yes for onto, yes for one-to-one, maybe. So the second one, we look on the second one, F2. F2 mapping from A to D. Why A to D? Because this utilize A and D. So this all element in A, this all element D. So we will draw another mapping. A map to D. So we have A, we have D. So this relation represented by F2. So F2. So F2 have A here, A1, A2, A3. A2, A3, dot, dot, dot. So D. D1, D have D1, D2, D3, D4. So D1, D2, D3, D4. Sorry. So F2 said that A1 map to D2, A1 map to D2, A2 map to D1, A2 map to D1, A3 map to D4, A3 map to D4. Okay, now we check. Is that everywhere defined? All the element in A utilized? Yes, everywhere defined. Is that onto? We look on this. This is not onto because D3 do not utilize. So this is not onto. Is that one-to-one? No, because D do not utilize. Here 3, here 4, so cannot be because 3, 4 cannot be. So it's not on to a one-to-one. Now we check function F3. So B and C. So we look on B and C. So we create another relation. B and C. Okay, here. B and C. Here. So C, we have two elements. C1, C2. So it says B1 map to B2. B1 map to C2, sorry. B1 map to C2. B2 map C2. B2 map C2. B3 map C1. B3 map C1. Okay. So we check. Is that everywhere defined? Yes, everywhere defined. Why? Because all the element in B map to C utilize. 1, 2, 3 utilize. Yes. So is that onto? We look onto. Yes, onto. Yes, onto. Is that one-to-one? No, because B1 and B2 map to C2 is not on one-to-one. Okay, now F4, D and B. Okay, we draw. Sorry. Okay, we assume that D map to B. So we assume this is another set B. D map to B. So this is F4. This one is F3. So B have 1, 2, 3. B1, B2, B3. So dot dot dot. So the mapping F function for D1, B1. D1 map to B1. D2 map to B2. D3 map to B1. D3 map to B1. Now we check. Is that everywhere defined? Here, no, because D4 do not utilize. D as a domain, D4 do not utilize. No. So is that on 2? We look on B. Still not on 2 because B3 do not utilize. They have no mapping to B3. So no. So how about 1 to 1? No. 1 to 1 because here D3 and D1 map to B1. So this is not 1 to 1 mapping. So all this answer we put here. So this is example 2. So any question for example 2? Okay, when you say why F2 not 1 to 1? F2 not 1 to 1. F2, where is F2? F2, where is F2? Huh? Here. Because F2, because we do not utilize D3. Why not 1 to 1? Because A map to D, but D do not utilize. It means if we want to get 1 to 1, if here 3, here should be 3, and mapping is one of from here to here 1 to 1. But here have 3. Yes, this we utilize. But for this we do not utilize. Supposedly, in order to make sure F3 is 1 to 1, we need to add one more in A. It means must have their pair. If here 4, here must also be 4. Here 3, here 4 cannot be as 1 to 1. 1 to 1 relation means straightforward. If there are 4 person, 4 men, we need to find that another group is 4 women. So we can put 1 to 1. So the answer is wrong. Yes. Okay. The answer is wrong. Yes. It means not 1 to 1. We do not say wrong. We say not 1 to 1. Okay, clear? Okay, now. Okay, not 1 to 1. This is the answer for example 2. Okay, then bijection. Bijection is a function. As specific, we focus on a function. But bijection, we need focus on 1-to-1 function. We call bijection. So we have relation. There are 4 types of relation: 1-to-1, many-to-1, 1-to-many, many-to-many, many-to-many. Only these 2 is a function. Based on these 2, only one type of function we call bijection. Bijection once is referred to function 1-to-1. So that's a bijection. So we assume that if we have a function A map to B is a 1-to-1 function, means we call this A. So we call bijection. So the F assigned to each element from element A of domain and element B in range. So every B in range is mesh. It means with only one element of domain. That's we call bijection. For example, we have A here, we have B. This function is a bijection. Once we have here, we have 1, 2, 3. Here also must have 3 elements. A, for example, A, B, C. If you map it like this one, so this is one-to-one relation. So this is bijection. So in other words, it's also everywhere defined. It also one-to-one, and it we call one-to-one correspondent. So once it fulfill this one, fulfill this one, fulfill this one, then we call as a bijection. Okay. Bijection means fulfill all the conditions. Because F2 1-to-1 F2 1-to-1. No. Okay. No, because this is not utilized this one. Okay. Okay, Kai. So this one is no. Okay. Now we still talk about bijection. So bijection means we fulfill all these three special type. One, fulfill this one, fulfill this one, fulfill this one, we call bijection. Okay. For example, this one is not bijection, this one is special, one-to-one. Okay. Now that's about bijection. Kejap, kelas. Okay, sorry kelas. Okay, bijection, this is a bijection means one-to-one. And if we have 2 elements, here must have also 2 elements involved. Okay, now we talk about invertible function. Invertible function, we refer to inverse relation. Means we refer to f power of minus 1. So it is also a function. If that function can be inverse, we call invertible function. For example, here, given to you A equal to 1, 2, 3, 4, B equal to A, B, C, D. So try to find either F1 and F2 is that invertible function or not. We look on this 1A, 2A, 3C, 4D, and the second function is 1A, 2C, 3B, and 4D. So we look here. So when we inverse the process, it means we change the position from here to here, here to here. So it will be A1, A2, C3, D4. So is that once we look on the relation, when we inverse the position, previously this one is 1A, 2A, 3C, and then 4D. So when we inverse from here F, we inverse F1, it will be inverse of function for F1, it will be like this answer. So this is not a function since once we have one too many here. Once we inverse, it will be one too many. A map to 1, A map to B. So this is not a function. So once it's not a function, so we cannot declare as invertible function. Okay? F2. So F2 given to you here, F2, 1A, 2C, 3B, 4D. Once we inverse this, it changes the position. So it will be A1, C2, B3, D4. Change the position. So we check. A map to 1, C map to 2, B map to 3, D map to 4. Actually, it's 1-to-1 relation. So once it 1-to-1 relation, so it also a function. So because of we can get once we inverse this position, it 1-to-1. So we can call this function is a invertible function. That's it. We just only check once we inverse. We just only check the type of mapping. Here is 1-to-1. Here is one to many. That's why here we cannot call invertible function. For instance, this one we can call it is a invertible function. Okay. Now the invertible function we represent by equation. So we have A map to B. So we have first FA represented by A plus 1. So FB A power of 3 plus 1. So what is the invertible function for F A here? So once we inverse this function, it means we inverse this equation, so it will be equal to A plus 1, we assume equal to F. We try to find all equal to A, so we put 1 to here. It will be F minus 1 equal to A. So invertible function will be F1 equal to A minus 1. So that's the answer. So this one actually is, once we put here back to A, because actually it's A, so it will be A minus 1, A will be the A minus 1. So the invertible function of A plus 1 actually A minus 1. So this one, invertible function of A, it will be, we put as here we put as F1 A 3 plus 1. So it will be, this one it will be F1 minus 1 equal to A power of 3. So it will be A, this one, we focus on this one, minus 1 square 3 will be A. So F A, actually A equal to 3 A minus 1. So that's why it will be like this one. We change to F A equal to A minus 1 3. So from A, from FA, inverse of A will be A minus 1 square root 3. So this is the answer. This is the answer. So once inverse function, we deal with the function itself. So we need to solve the problem like this solution. Okay. Yeah. Okay. This is exercise for you. Try to do this exercise by yourself. Already have the answer. See, this is the answer given to you. X plus 1 divided by 2. Try to find inverse of this function. So firstly, we put this X as a Y.
Okay, this exercise you all do.
So
answer already.
if you change the position, 2 put to here, it will be 2 times Y. So here X plus 1, put this 1 to here, negative 1. So it will be like this one. So the final answer is inverse function for X actually is 2X minus 1. That's the answer. Okay, that one is 4.1b, special type and invertible function. So far, any question? Saraya? Okay, for your version, I would like to ask you, related to this slide, I would like to ask you a question, look like this one. Look like this exercise. Oh, sorry. Look like, okay, this one. Look like this exercise. Okay, please try to understand this exercise, because your test or your assignment, at least one question will came from this exercise, this type of exercise. Look similar with this one. Okay. Okay, class, anything? If there is no question, I think we can stop here for today's class. Okay? Class, okay? Amar, okay? Good. Sharon? Okay. Vicky, okay? Nazifa, okay? Okay. If everything okay, so that's it for today. Thank you very much.
Yeah.
Okay, thank you, Ismail. So about your test, don't know yet. I try to finish all the lesson first. Okay, thank you, bye-bye. Attendant, okay, attendant, I will share with you your attendant, huh?